Hello everyone, this is Kerstin from IDC. Thank you for joining us today for this live webcast on the next generation of data integration enabled by Semantic Technologies. Before handing over to our first speaker, I would like to point out that you can ask questions at any point during the presentations via the Q&A box on the right-hand side of your screen. The questions will only be visible to the speakers and will be answered at the end of this webcast or via email. Now I would like to hand over to our first speaker, Tom Wawra.
Thank you, Kerstin, and welcome everyone. Digital transformation increasingly is becoming a key focal point of strategy for companies across Europe. At the core of any digital transformation initiative is data. Without data integrity, we'll not be able to support digital transformation initiatives. Nevertheless, data integration software vendors do have the tools, intellectual property, and products that can help companies improve the integrity of their data. And data integrity has become a new focus of efforts in the broader big data analytics space, and as noted, as a core element of digital transformation. In my brief introduction today, I'd like to address where we stand with that and some of the ways in which IDC sees the situation unfolding. Of course, there are a number of challenges that companies face when assessing and categorizing their data and how they approach it. For example, in IDC's research, unstructured content, that is to say email, video, instant messages, documents of all other formats, account for 90% of all digital information today. Now, unlocking the value from that content should be the goal of every organization, but to date, relatively few have gone about that in any sort of concerted way. As such, that data and the vast promise and untapped value that it represents is still locked away in all types of applications and separate repositories that don't necessarily talk to each other. And that's become a key issue that needs to be addressed by all companies moving down the digital transformation path, and is certainly as a central focus for any of their big data and analytics initiatives. So why do, in fact, then, so few organizations find value in their information? IDC has found that worldwide, 61% of knowledge workers regularly access 4 or more systems to get the information they need to do their jobs. 36% of typical knowledge workers' day is spent looking for and consolidating information spread across all of those systems. Moreover, nearly 15% access 11 or more systems to get at the information that they need. And 50% of these workers find the information required to do their jobs only 56% of the time. Consequently, we're in a situation where it's clear that we're not doing a very good job of maximizing data potential, nor are we doing what we can to support information workers in doing their jobs better and more effectively. So with that, what I'd like to do is take a look at a couple of key predictions that IDC has made for the big data and analytics space, because they will become quite important and relevant. Firstly, through 2020, spending on self-service visual discovery and data preparation market will grow at 2.5 times faster than traditional IT-controlled tools of similar functionality. There is a key and very important focus on self-service at the moment, and that will become very critical to all companies looking to move forward in this area. Similarly, by 2020, data monetization efforts will result in enterprises pursuing digital transformation initiatives increasing the marketplace's consumption of their own data by 100-fold or more. Take a moment to just imagine that figure. Also, by 2020, the high-value data part of the digital university is worth analyzing to achieve actionable intelligence will double. And lastly, again, by 2020, IDC predicts that 60% of information delivered to decision makers will be considered by them always actionable, which is double the current rate that we see right now. So what that means in reality is that it's clear the amount of what we can be analyzed continues to grow at remarkable rates. That's been going on for quite some time, and it's not slowing down in any appreciable way. However, if you're not in a position to capitalize on it, then you're losing ground. Consider that last prediction on the screen. 60% of information delivered to decision makers by 2020 will be considered by them always actionable. Now consider your own situation in your companies and organizations, and assess where you stand with that. And if you're not counting yourself in that 60%, then of companies that are delivering 60% actionable, always actionable information, then you're already behind the game, and that's something of concern for management. Now, looking more specifically at market data trends that IDC has been researching starting with 2015 as a base point forecast through 2020. Here we see a number of technologies that are focused on data integration and integrity, and the growth rates that we expect for them. And clearly, those growth rates are far in excess of what we expect for the general IT market. They're growing at a much faster rate by a considerable margin. Yet, among them, there are a few that stand out: self-service data preparation, metadata management, and master data definition and control. These are all that are outpacing even this already fast-moving data integration and integrity market. Now, how is that relevant? We just spoke about some of the predictions that IDC has in the broader big data analytics space and the focus on self-service, and clearly that's in evidence now because the market is moving in that way, in that companies are seeking out technologies that allow them to provide that self-service to their knowledge workers. Similarly, metadata management and master data definition have become central to a lot of companies' efforts in the broader big data space, and which indicates a recognition of the fact that companies have lagged behind in this area. They've not done a great deal to address unstructured data sources, and that's starting to change now rather quickly, and the market is catching up, and companies are moving very quickly into that space. So those predictions I just spoke about are somewhat confirmed in IDC's own market research and data, because it shows the market is moving in that direction already. But beyond let's say, the general big data analytics discussion and the centrality and importance of data integrity and integration that it plays in that broader question, there's another element to consider as well. And that's the importance of semantics, my final topic. Here we have a representation of a 4-layer content architecture where we have content, metadata, semantics, and the navigational layers. Think of the semantic layer as a single access point for metadata management, which provides a 360-degree view, if you like, of business objects and their usage. For those who may not be fully familiar with them, Semantic Technologies provide a complete tool set for enriching structured and unstructured data with metadata and establishing a contextual framework for organizational data repositories, and which means that documents are analyzed at an entity level, and there's an entity-centric view. And that's why the semantic layer has become, let's say, the next key area where companies will need to focus if they wish to maximize on their efforts. What benefits can semantic technologies bring? First of all, it's a graph-based technology approach which enables agile data processing of both structured and unstructured content. Semantic technologies are standards-based, and organizations avoid vendor look-in and can start building a more sustainable organizational data management infrastructure. At this point already, despite let's say, the adoption levels that we may see here in Europe, semantic technologies are in fact mature, and we see that in evidence for a lot of Fortune 500 companies who are successfully, utilizing semantic technologies. So that's what semantic technologies can offer, and as I said, this will become a key area of investment and focus for companies who are looking to move to the next step, the next stage of their development of their big data and analytics projects. So in summary, we've seen how data access and integration will become a key area of focus for companies who are seeking to make the most of their various untapped data assets that they may have. Also, we're seeing increased recognition of the lack of attention that has been paid thus far, and has strengthened in industries, and companies are starting to invest more in the types of technologies that can help them succeed in their big data, analytics, and even cognitive-focused efforts. And lastly, semantic technologies now represent the next key element of success that will provide even greater value and advantage to those who are deploying them when it comes to maximizing the return on the investment in such projects. With that, I will conclude my presentation, and I will turn it over to Andreas Blum, CEO, Semantic Web Company, and Product Architect for PoolParty Semantic Suite. Andreas, the floor is yours.
Thank you, Tom. Thanks for the introduction and for you making the point of the benefit and value companies can gain from the applications based on a semantic web infrastructure. And in my part of the talk, I will go into more into the details, how that is structured, how it can be maintained, how it can be applied. And at the end of this part, I will also give you a live demo, so please stay with us. So I will start with a very brief introduction of my background. I use a knowledge graph for that purpose, so you can see we make use of semantic technologies even when something has to be introduced. So in that case, my name is Andreas. I'm the founder, one of the 3 founders and the CEO of the Semantic Web Company. We are located in Vienna. Back in 2004, we were founded, so since quite a while on the market, pioneering the semantic web in the very first years. And in 2009, actually, the W3C, Tom already mentioned, semantic web technologies are based on standards, mostly provided by the W3C. And back in 2009, it was about time to go to market with a product. Most of the core elements of the semantic web have been defined at that time. And since then, more and more enterprises started to adapt those technologies for internal data integration projects, search projects, knowledge discovery, and similar stuff. As you can see, one of the core standards of the semantic web is the so-called SKOS standard. That stands for Simple Knowledge Organization System. And with that, you mainly produce rather simple knowledge models called taxonomies and thesauri. And in order to extend those, you can use our software and introduce ontologies and make more and more extensive knowledge graphs out of that. And I think one of the most exciting features and interesting parts of the semantic web is the fact that there are millions or billions of facts around already. So you can reuse existing data sources like DPpedia or Wikidata, and most of those are used by the internet giants like Google as well. So you can actually transfer those technologies used by internet search engines into your own environment. And you can imagine it's a very agile approach. That was also something Tom already pointed out. With a graph-based approach, as we are taking here, it's quite easy in a way to extend the data model step by step, really in parallel to the needs of your business departments. And you can expose parts of that knowledge to your partners in your, let's say, linked data value chain, in your content value chain. If you have some providers on the one hand side or some suppliers, and on the other hand side, your clients, you might be interested to exchange data from here to there. And some of those standards on top of the W3C standards are heavily in use, like schema.org. Schema.org is an ontology which is mainly in use by, again, the internet companies like Google and so on. And you can use a similar approach also for internal data modeling in order to do data integration on a very agile basis. So that's really the basic introduction, the whole story here. And I already used a couple of words, taxonomies, ontologies, knowledge graphs. So let's take a look on that. What's really a taxonomy and so on. As Tom already pointed out, it's a four-layered content architecture. So most of you are, of course, familiar with the idea of having metadata on top of content assets and any kind of data. But with metadata per data silo, you don't solve the integration task yet. So what you need on top of your metadata is semantics, which describes the meaning of your metadata, which describes how metadata is related to each other. And it's an entity-centric view. It's not a document-centric view anymore. So in our days, you see more and more initiatives in which publishing processes tend to produce content assets, digital assets, which are really broken down to their smallest size, so to speak. So the idea is really to put the information silos aside and have a different data model on top of that. So it's not, there's no need to migrate the data really. It's kind of an extra layer on top of the existing data repositories, but they provide the application developers with an extra information layer, which is about the meaning of the data, which can be found inside your silos. And that, at the end, will bring up a more integrated view over your data to the customers, to the clients, if they are in search for a product configuration maybe, or in your departments when, let's say, product developers are in search of the right configuration options for developing new products, and so on and so forth. So that's the abstract view on what we call the four-layered content architecture. And you can use that, for instance, if we look at a domain like e-commerce to do personalization. That would be one typical application, because your description of your clients and the description of your products, your campaigns, your content will follow the same kind of semantics you describe explicitly in your semantic layer by using a taxonomy plus maybe an ontology or a couple of those, probably enriched by data from your product repositories, from your product catalogs, maybe from your content management system in which you store news stories around your, let's say, products or any related stuff. In any case, what you are going to produce on top of, in that case, of your product catalog is an extra semantic layer in which you store and classify metadata. But it's explicitly available. That means it can also connect to your customer relationship management system, maybe, or to your campaign management system. So it's really an extra data layer on top, and it's not stored anymore inside your application logics. It's not stored or locked in your data silo. It's an asset on its own, and that's the basic idea of introducing an enterprise semantic web layer. So you could put it into this simple table. With semantic web technologies in place, you have either a knowledge management perspective on it or maybe a rather user experience e-commerce perspective. In any case, you use the same technologies. On the left-hand side, it could be management of controlled vocabularies to make people communicate in a more efficient way. Same technologies can be used to translate jargon into clients' needs. That's a typical problem at any e-commerce solution, that vendors and producers tend to use terms and phrases not well interpreted by the clients later. So that's, again, an application of the semantic web. Of course, content discovery, cross-selling, that would be yet another application. If you look at your knowledge assets, pretty much the same principle. You would like to make it more transparent to your clients, what can be discovered related to objects or documents already found by the user. And of course, with a graph database in the background, it's possible to do execute complex queries, and not just the ones we are used when looking at typical search engines. And it's possible to do analytics over heterogeneous data sets. You can link data from relational databases to unstructured data. And I will show you an example at the end of this video. And on the user experience side, of course, it's important to have assistance in place. Search engines which go beyond simple search queries. It goes towards query and answering machines which understand your actual needs, maybe behind the question you're asking even. So the concept behind, that's what the user is expecting from a search engine, as we call it in our days still, and which goes more and more towards a personal assistant. And personalization is not only on the web, in the e-commerce field, so important, it's also getting more and more important in the enterprise field. When looking at this tremendous growth of data, you need to have systems which push data and information to your processes, really put into the right context. So if you look at this generic typical application scenarios on top of a semantic web infrastructure, it would be a knowledge and discovery and visualization application. So it's a kind of a follow your nose principle you would provide here. Users can discover assets which can help them to do their business in a more efficient way. Then next generic application is an analytics dashboard, which can execute complex queries over an integrated virtualized data set, which goes clearly beyond the typical search for where is the next pizza. So in that case, you would not necessarily need a semantic layer on top. And last but not least, the 360-degree views on business objects. You could call them also topic or landing pages. And that's something we are completely missing in our companies most frequently. So what we do actually to substitute those missing applications is kind of a handcrafted data integration every day, putting together the information from different data silos using maybe a desktop tool like, I don't know, Excel or a notebook or whatever, a notes application where you put your data in and then later you integrate it really by hand. And with the semantic web on top, you can do most parts of that automatically. So how does it work? Let's take a look on the anatomy of a knowledge graph. So remember, the precondition to be able to build such applications on top of the data is always a semantic layer. The semantic layer is actually a knowledge graph which can consist of several components. First of all, it's about the instance data, of course. So in that little example here, which is about, let's say, the tourism industry, you would have instance data like places, squares, and tourist attractions and things like that. Of course, one of the first things you would already do at that point is to come up with the different names and identifiers maybe you can find in your different systems for any of those instances. And you could start to relate those to each other. As a next step, you would like to introduce schema data. So at the moment, you've got the situation, or you're confronted with the situation that in any of your data sources, you usually use different schemas. An Excel sheet has its own schema. A relational database, of course, provides schema data. But the problem is it's let's say, a more or less implicit semantics being used here. You have to interpret it in a way it's not machine readable. The schema you're using all over the places are, of course, not linked to each other. They are different, even if the same things are meant at different places. So it would be a good idea if you were able to provide to the data engineers and application developers throughout your enterprise a schema or vocabulary service, which is centralized, which can be accessed at any point in the company, maybe parts of them even from the outside. And that's done by the introduction of ontologies and schemas. And therefore, RDF, which is the standard in the semantic web, was developed as a language to come up with schema data on a universal level. It can be mapped to any existing data source you could think of at the moment. So in one example here is schema.org. Again, quite comprehensive ontology used in many different systems in the meantime. And you can classify your instance data by that. As you see, Venice now has become a city, or the Beckett Guggenheim Museum is now an art gallery. It's not just anything like before. It's something specific. And therefore, of course, you can introduce attributes and properties between those instance data, which is allowed and which makes sense. So with a schema and an ontology, you can come up also with rules when your data stays consistent and which relations between the things make sense. As a next step, of course, metadata is everywhere, and metadata in that sense means, for instance, with an image, to attach usage rights. That could be a typical metadata on top of your instance data, on top of your assets. And that should, of course, also be expressed via the very same standard, in that case, the RDF standard, and Creative Commons, that's a typical metadata schema to describe usage rights of images and other digital assets. So that's quite compatible with any other graph-based component. No problem to include existing metadata in your knowledge graph. And as a next step, taxonomies and thesauri will play an important role to further extend your knowledge graph. You can state that, for instance, in that case, St. Mark's Square which can also be named Piazza San Marco, very same thing, and it's kind of a piazza, it's a town square. And by that, you can later ask more complex queries, as you can imagine, asking things like which cities in Italy have a town square, which is close to a museum, which is about, and so on and so forth. And for that reason, you would most probably use the W3C standards costs. And then, as a next step, you can come up with links between your internal knowledge graph, maybe other internal knowledge graphs. The knowledge graph is not necessarily just one monolithic data structure in your organization. It could consist of several knowledge graphs being linked to each other. So you can do mappings between those components and also to the external sources. You could include relational databases. At that point, no worries if your data is mainly still not a graph-based data structure. You can quite easily transform any kind of data, even unstructured, into a graph-based structure. But in that case, you see the Peggy Guggenheim Museum, maybe one of your data objects in your internal database will be mapped to external sources like DPpedia, and from there you can fetch a lot of extra information and enrich your applications at nearly zero costs. Of course, data quality is something you have to keep an eye on. At that point, it's something which has to be, let's say, developed to a certain degree then later by your own data engineers and content managers. But if you look at data sources like GeoNames, which is available as an RDF database, it has extremely high quality. It covers nearly any geospatial thing on planet Earth. There's a lot of extra information. You can easily enrich your internal database by that. And I believe it doesn't make sense that geodatabases are maintained again and again by the enterprises themselves. That's typically something a company which is specialized in that topic should do, and then later provide it and to be included in your own applications without a big effort, at least from a technical perspective. And GeoNames you can consume on different service level agreements. You can say, okay, I want to have that highly available. You can download the whole dump, for instance. But the great thing, since it's in RDF and standards-based, you can easily link your internal data with this external source, and the data integration effort is technically spoken zero. And last but not least, and I think that's for enterprises, of course, the most important fact, any of those knowledge graph components I've mentioned so far can then automatically be linked to your relational databases, your XML repositories, and even to your unstructured information. So the unstructured information here, for instance, is highlighted a document about the Peggy Guggenheim collection, which is a synonym of Peggy Guggenheim Museum, still will be found as an entity in this text, and Venice, Italy, of course, as well. And by that, your unstructured information will be linked, so to speak, to the knowledge graph. And now you can access your text repositories in a totally different way than you could do with a full text index. With a full text index, obviously, you just can look up documents which contain a certain phrase or word. Great. Okay. We should go beyond that, I guess. If you look at Google, there was a large investment in the last 5 or 10 years even into the establishment or the production of an extensive knowledge graph. Google's knowledge graph now contains billions of entities in the meantime. But of course, this structure cannot serve the specific needs of an enterprise, a manufacturer of vehicles, for instance, or a pharma company has totally different entities and business objects in place, other names, and so on. So actually the approach taken by Google makes a lot of sense, but you can imagine as an enterprise, you have to keep an eye on your own enterprise knowledge graph. You cannot buy that or outsource that kind of work. It has to be professionally managed, and a knowledge graph has to grow over the years, parallel actually to your business logics, to your extension of what you cover. Your inventions and innovations, of course, should be reflected in the overall market developments. If you're on an agile market, of course, also that should be reflected in your knowledge graph. Well, I'm not saying that the knowledge graph is necessarily the model of your whole corporation. Usually, when we look at projects which currently go on, and Tom said it's the future, I say it's the present. We are working with a lot of large Fortune 500 companies in this area, also with small and medium, or rather medium companies in this area. And they are all, of course, now looking into ways to develop such knowledge graphs. So what are the methodologies behind? And I'd like to cover that also in the next part of my talk. So what are the use cases? I think that's something which, clearly spoken, is one of the first things the companies using this technology should be clear about. Defining the use case, on the other hand side, doesn't mean that you have a strategy. So we've seen in recent years lots of companies starting with maybe a particular use case. Okay, let's improve search, maybe. That's typically a low-hanging fruit for semantic technologies. And it's very true. There should be a benefit triggered quickly, on the one hand side. On the other hand side, semantic web technologies are not necessarily coming to its full potential when being used only in one particular application scenario. It's an integration technologies, and companies benefit most of it when connecting data from different data repositories, different structures, internal, external, text, semi-structured, XML, and so on. So actually, it means that it's a strategic approach for information management in general. And that's something more and more companies understand. So it's actually a middle-out approach, so to speak. So there should be a strategy on the one hand side. So where are we going with linked data technologies? Linked data is just a synonym for semantic web, by the way. So into which direction should we go with linked data technologies? And this example in front of you, the Health Direct Australia, that was something which was done in parallel. So when we started to work with them, they had already quite a clear vision about how to use linked data in the long run. On the other hand, they were able to produce quickly an application which triggered a lot of benefit to the Australian citizens. So the Health Direct Australia is kind of the one-stop shop for Australian citizens to get high-quality information around healthcare. And it consists of smart assistants like the symptom checker. It can integrate data from over 100 information sources. It produces topic and landing pages. It can now also inform the citizens about treatments and doctors in the neighborhood. And anything is linked together. That's the great story around it. And people can be sure that all the data is of high quality. And in the back end, they've produced a quite extensive knowledge graph. In its core, the Australian Health Thesaurus does a good job. And it contains things like body parts, drugs, treatments, symptoms, and so on and so forth. And it's growing. So also the incoming data is being analyzed constantly, and by that, the knowledge graph is extended every day. When looking at that little example, that already explains quite well into which direction e-commerce will go. So many of our clients are looking into knowledge graphs because they can build a great basis for machine learning components. As we all know, machine learning only works well to a certain degree if the machine can rely on a certain knowledge model, first of all. If you just put in unstructured stuff and expect to have the perfect question answering machine at the end, doesn't work. You need a structure, and a knowledge graph is a great way to start with. And a couple of our customers use knowledge graphs and taxonomies to feed their machine learning algorithms. And what it can do on top of that is there are several things you can do. Of course, recommender engines, like, okay, if people buy a certain product or are interested in a certain product, then they should be or could be interested also in something similar. So that's the basic idea of a recommender system. But the other problem which can be solved with a knowledge graph is to better embed specific information in a piece of content. So what you see here is a simple example of a recipe of a strawberry coconut shaved ice. And then as a vendor of some devices you might need for the preparation of this recipe, it would be great to have that embedded as specifically as possible, not just in a box somewhere on top which says, okay, if you want to prepare this, you might be interested in that product. It should be exactly at that point in your recipe where you need it. And how can you produce such a structure? And if you look at XML tools like Font2XML, which is a great XML editor, you can embed this semantic information inside your XML structures. And PoolParty can help you with doing that, first of all, based on a consistent vocabulary, and second of all, by analyzing the text automatically, or actually semi-automatically, recommending, okay, which products should be recommended at which point of your text. So that's the way e-commerce will be combined more and more with content marketing. Of course, it's not necessarily only restricted to e-commerce. You can imagine any working instruction in a bank or so, or in a atomic power station would also benefit if certain information would be embedded right at the point where it should be put to. So that's also something very important to understand, that with a semantic knowledge graph, you can break down your content assets, first of all, into the smallest possible information chunks, pieces of information, and then enrich only those little pieces by the most relevant information just at that point. So we break apart the document as a container. It's just, documents are really just a representation layer on top of our data anymore. The document is nothing we can use anymore actually to serve the needs of our clients really, because they are asking questions and they don't want to get documents, they want to get answers. And that's the point I would like to make here. And then as another generic use case, analytics and complex queries are a very promising field of activity for semantic applications. I will show you an example after this presentation, which also gives a better insight into what's behind the scenes when producing an application like that. I'm not saying it wouldn't be possible with classical technologies for data integration, but the point is you just save a lot of time when using RDF and semantic web technologies. At least when you look at how the synergies will increase over time. I'm not saying that it's probably from the very first beginning that semantic web technologies will help you to save a lot of costs and time in producing such applications, but you can reuse the semantics stored in your semantic layer again and again and again, because it produces explicit semantics of your business based on standards. you no longer use your or misuse actually your databases to store semantics in it. It's a clear split between the data as we know it, the metadata on top, and the semantics on top. And by that, you can produce such analytics dashboard over various data sources more or less on the fly. And that's the great thing about it. So as an example, you see a little screenshot here, which is derived from our SharePoint and Office 365 integration. You can enrich, if you like, your internal SharePoint data by external data. You can also come up with a information box. So if you look at certain topics like wind farms, then of course it will be pushed into the search index together with all the different synonyms you might find for wind farms, like windmills and stuff. That's a simple semantic query expansion. But on top of that, you can also find context information around wind farms. You can configure that quite easily. You can enrich the knowledge graph from databases, internal, external, and then come up with a dashboard like that. So as you can see, it's no longer just search for documents, but also search for knowledge around certain things. Could be anything, could be a client, could be a product, could be a vendor, a technology, whatever. So technologies like that will transform search towards knowledge machines, so to speak. Search over documents is really just one component of that. And then, as a little example here, as an e-commerce vendor, for instance, as a provider, as a vendor of, let's say, in that case, outdoor equipment, you might be interested in the provision of a special service to your clients, which is about personalization. So how can that be done? Of course, after certain interactions your client has made with your system, you will be able to tell around about what the interest of this person is. Same thing in the internal enterprise information system. You know what their skills are, what their interests are. They can dynamically adapt over the time, of course. But in any case, you always have to map those interactions to the products, which could be, in that case, an outdoor equipment. In other cases, maybe a therapy, which could fit with the symptoms and stuff. So it's always pretty much the same when it comes to personalization recommendation, at least on a technical perspective. And in order to configure the machine behind this recommendation, you need to come up with a knowledge graph. Again, it's an important precondition. And from there, you can start your machine learning activities to improve the recommender system. But the basis for that most frequently is a semantic knowledge graph. Now, in the last part of my presentation, I'd like to give you a very brief introduction to PoolParty Semantic Suite. PoolParty is a tool which can be used as a semantic middleware. It comes with a couple of user-friendly interfaces and a full-blown RESTful API, which means you can access all the data in your knowledge graph. So the PoolParty server, you can update and do any crude methods on top. There is also so in that case, maybe I start first with that. That's the environment where you typically maintain taxonomies. On top of that, you can maintain ontologies, the links, the mappings and stuff I described before. So you can bring your knowledge graph up to speed with this tool. That's one of the main components of the suite. And then as another component, Entity extraction and entity linking can be done with PoolParty, which means any kind of information, in that case it's unstructured text, can be linked to your knowledge graph. That's done automatically in the background. There is, again, APIs. You can easily integrate that service into your content workflows and data production workflows. And so in that case, you see how different aspects, objects, also actions in your text and any kind of data can be annotated. So this can be done virtually at any point of your content workflows, your content production pipeline. It's either a push or a pull, so that means either the data from PoolParty can be used to enrich the content, or the content can be analyzed and maybe enriched by other content repositories. In any case, most frequently the REST APIs of PoolParty will be used. You can use it to better support content creators. You can use it for content linking, for the publishing process. It can be used, for instance, to better make it available for search engine optimization, for retrieval. I think that's the most obvious case. You can use the same technology. And what's not that obvious, I guess, is data and content quality in general. As soon as semantics is explicitly available, which describes your assets, you can do several tests on the quality of your data, if it's consistent, if there are contradictions and stuff like that. So that's also maybe an aspect you shouldn't forget about. So to sum it up, PoolParty is built as a semantic middleware. There are several integrations in place with various content platforms like SharePoint, Drupal, Alfresco, Umbraco, and others. You can use PoolParty to integrate that with your search engine. There are already a couple of search engines integrated with PoolParty, like Elasticsearch or Solar or Sinequa. Also commercial vendors like Sinequa or Mindbreeze have an integration with PoolParty. And we go also beyond the, let's say, rather traditional search engines and use graph databases. As Tom mentioned initially, that's one of the core, let's say, technologies being used in an architecture like that. So we integrate with graph databases like MarkLogic, Stardock, GraphDB, or Virtuoso. So I think that's about it, more or less. And now I would like to briefly show what's going on in the actual graphical user interface when those taxonomies and ontologies come to life. So I will now log in. First, we'll switch on the screen sharing tool here in this presentation software. So it's now starting, and you should see now the login screen. I will now log into the back end of the system where the knowledge graphs are maintained. I will load one of the taxonomies which are stored on that server. So it's a software environment which can keep many taxonomies in the database and many different entity extraction services. I will load one of those, which is a very simple taxonomy, also used by, for instance, the Asian Development Bank. So it has a couple of topics here. As you can see, that's the tree visualization here. There are countries, there are regions, so they are organized in hierarchies and so on. I will show you a very simple example how to extend that. So for instance, here we've got some countries classified as non-regional. For instance, Austria. If you click on Austria, you get a very simple interface to extend all the taxonomical properties here. So on the left-hand side, simple relations. You can drag and drop quite easily and say, for instance, Austria is for whatever reason, related to Portugal and Spain maybe. You can put there different labels. So for instance, also of course in different languages, I can put there an ISO code of Austria. So you see it's the very same thing. It has one identifier that's up here, and it has different names. And that's one of the most important, let's say, features a semantic knowledge graph can deliver, which means we are looking on things, not strings anymore. That means the string, Aut or AT or Austria, all means the same thing. Of course, then we have to cover a couple of linguistic features like synonyms and homographs and polyhierarchies. That means Austria could mean different things, or maybe a good example for that would be Jaguar, which can be a cat or a car. And of course, the system has to figure out later when finding Jaguar what's meant in that context. And that's also something the machine can do quite nicely when a knowledge graph is in place. So that's just a simple backend. Of course, there are lots of different features we cannot cover in this short webinar. So on top of such a knowledge graph, you can then produce an application like that. First of all, it's an application which consumes a lot of different data sources, which got integrated in that case on top of a taxonomy. So the goal of that application is to better understand in a pharmaceutical industry or company its own research activities, which is distributed, which was stored in former years in different silos, different Excel sheets, different databases. It was not linked to other databases provided by publishers like Wolters Kluwer. They have a lot of numerical data also on top of research papers, like impact factors and who is the author and stuff like that. And all that got better structured and integrated by using the PoolParty Semantic Suite. So you can, of course, filter out quickly and say, I'm only interested in applied research. I'm maybe interested just in a certain location, and so on. As you see, you not only get a bunch of documents, you also get already statistics on top, which shows you in which therapeutic area, for instance, those documents are mainly located. You can visualize different things here quite quickly by using this selector up here. And the great thing is anything you see here is made available as a semantic knowledge graph. And that means you can reuse your data again and again in different application contexts. So you don't have to reinvent the wheel again and again. For instance, the taxonomies being produced here, which describe the organization structure of that company or the locations or other specificities, can be reused again and again. So you can enrich and grow your application over the years. And it's a very dynamic style to produce data in an integrated way. And last but not least, that's also a view on one of the PoolParty components, very important to understand. It's an ETL tool for RDF data. So you can extract data from relational databases, web APIs, whatsoever. You can transform them, you can enrich them, and then finally, in that case, load into a triple store, in that case, Virtuoso. And from there, you can do these complex queries I was mentioning before. And anything you see here, here, for instance, is really based on a Sparkle query. That's yet another standard, the query language for semantic knowledge graphs. Very powerful. You can do a lot of things. You can even combine it with R and stuff like that. Okay, a lot of information, I know. I will come to an end. We'll switch back to the slide deck and would like to let you know, please make sure to find your way to our website where you can try out the software. So just go to www.poolparty.biz/demo. If you go to /academy, you can get certified. We have several training tracks, all self-paced. It's an e-learning platform you will find there. Just register for free for the first track. Get certified as a Semantic Web Associate if you like the idea of using these technologies in your own company. And later, there are other tracks, of course, and you will find your way quite quickly. That's also something I'd like to point out. It's not that complex as it was the years before anymore. It's all about user-friendliness to a certain degree, and it's all about understanding the concept behind. And I hope that Tom and I were able to bring you a little bit more into this field, which is I think a quite exciting new opportunity for all kinds of organizations to come up with a better information management strategy. So yeah, thank you very much for your attention, and I hope we connect soon.
Thank you. So unfortunately, we already went over time, so we will not have time for any questions now. But if you have any questions, please feel free to contact us via email. Thank you very much for joining this webcast, and have a nice day.